How's it going? Today we're going to talk about a very important chemistry concept. What's a mole? So a mole is a term that you're going to hear all the time in chemistry, and it tends to get overcomplicated. It's actually a really simple concept when you stop and think about it. So we're going to start off with a little analogy there. You go to the store and you decide to buy a dozen eggs, even if they're weird and brown looking like that. So if you get 1 dozen eggs, we all know how many eggs you have. You have 12 eggs. Everyone okay with that? Hopefully. So now you go to the store and you buy 4 dozen eggs. I don't know, you're having a omelet party or something like that. If you got 4 dozen eggs, how many eggs do you have? Well, hopefully you did the math in your head and didn't have to break out a calculator. But you have 48 eggs. So what you just did there, you said, well, I have 4 dozen eggs. And if we set up our conversion tree, 1 dozen eggs is 12 of them. So 4 times 12 is 48 eggs. We're going to use the same exact idea when we're using this concept of what a mole is here in chemistry. Well, as we know, in chemistry we're talking about atoms and molecules. And we know that atoms and molecules aren't actually very big. They're actually, I'm trying to shrink it right now, it's not going to let me. They're actually really tiny, minuscule things. So things that are made up of atoms and molecules, like a grain of salt, are made up of millions upon millions upon millions upon millions upon billions upon trillions, you get the picture, of those salt molecules. So in actuality, in chemistry, we're not talking about just a few atoms. We're talking about an astronomical amount of atoms and molecules, which we're going to call particles from now on. So everything on Earth, all matter, is made up of these astronomical level of particles. Well, chemists decided that they were sick of using these big, giant numbers when they were talking about how many particles they had in a sample. So instead, they created a shortcut. Just like 1 dozen is a shortcut for 12 eggs or 12 of something, a mole is a shortcut. 1 mole of a substance is 6.022 times 10 to the 23rd of that substance. So if you have a dozen donuts, you have 12 donuts. If you have a mole of donuts, you have diabetes. Just kidding. You have a lot of donuts there. You have 6.022 times 10 to the 23rd, which is a ton. It's a number that we can't even really fathom or imagine in our brains. So I wrote it out there with the zeros so that you could see in the commas. Right about here is the billionths place. Here's the trillions place then. So you can see it's a big number. It's a real big number. Since it's such a big number, there's really only one thing you're going to use it to talk about, and that's going to be particles, molecules, and atoms. That's really the only thing that on Earth that we're going to have that many of that we're going to need to use the term mole for. So unfortunately, you're probably not going to ever have a mole of donuts. So earlier we were talking about the eggs, and we said if you have 4 dozen eggs, that you actually have 48 of them, or 4 times 12, because 1 dozen equals 12. Well, what we're going to see is if you have 4 moles of atoms, how many do you have? Well, we know 1 mole is equal to 6.02 times 10 to the 23rd. That's called Avogadros number. If you have 4 moles, it's 4 times that amount. So you have quite a few molecules there. And so using this the way that we have kind of set up with dimensional analysis, what you would do is you would say, I have 4 moles of, let's say, aluminum atoms. You're going to set up a tree. As always, you put 4 moles over 1 because anything over itself is itself. 4 over 1 is 4. You put what you want to cancel on the bottom and what you want to go to on the top. So in this case, we want to cancel moles of aluminum and we want to go to atoms of aluminum. So if you have 4 moles of aluminum in 1 mole, there's 6.022 times 10 to the 23rd. So that's called your conversion factor right there, that middle part. And so moles would cancel out, and your answer would be 4 times 6.022 times 10 to the 23rd, or 2.4 times 10 to the 24th atoms of aluminum. And yeah, I didn't really pay attention to Sig Figs there. 4 has 1 Sig Fig, so technically it should be 2 times 10 to the 24th, right? I know you guys love Sig Figs. Similarly, if we were going the opposite way, we would do pretty much the same thing. So if I told you that you have 9.3 times 10 to the 23rd molecules of water, that wasn't a voice crack. If you have 9.3 times 10 to the 23rd molecules of water, and you're trying to convert that to how many moles it is, you set up your tree, put that number over 1. What you want to cancel out goes on the bottom, and that'd be molecules of water. And what you want to go to goes on the top, that'd be moles. So molecules is going to cancel out in this case. Now what's your conversion factor? Again, 1 mole is equal to 6.022 times 10 to the 23rd molecules. The only hard thing about this is putting it in your calculator. So when you put in your calculator, you put parentheses around the top number and the bottom number, or else it won't work out. A little cheat trick there is, since they both have that times 10 to the 23rd, you can get rid of that and just do 9.3 divided by 6.022. But either way is fine. Comes out to be 1.544, which we're going to round to 2 Sig Figs. So it'd be 1.5 moles of water. So you have 1.5 moles of water if you have 9.3 times 10 to the 23rd molecules of water. Okay, so let's do one more example here. So this question says, how many molecules are in 2.5 moles of titanium 4 nitride? So what you do again is set up your tree, put what you're given on the top. If you haven't figured it out, the MOL, that's the abbreviation for moles, because you know chemists were really lazy bunch, so we can't write out the extra E there. It just takes way too long. So you put what you're given on top, what you want to cancel on the bottom, which is going to be moles of titanium 4 nitride, and then what you want to go to on the top. We're trying to find how many molecules, so molecules will go on the top. And then set up your conversion factor. In 1 mole, there is 6.022 times 10 to the 23rd. This conversion factor should pretty much always be 1 to something or other. So 2.5 times 6.022 times 10 to the 23rd. Really what you could just do is 2.5 times 6.022 times, and then put your answer times 10 to the 23rd. Or you could just type into your calculator. Either way works. But 2.5 times, sorry, Bell. 2.5 times 6.022 is 15. So it's 15 times 10 to the 23rd. Should have 2 Sig Figs, because 2.5 has 2 Sig Figs. Or the right way to write that is 1.5 times 10 to the 24th. And you always need to label what you're getting. So that's molecules of titanium 3 nitride. So there's a lot of molecules in 2.5 moles. That makes sense. Alright, well hopefully this helped you out. If you will, check out my next video that's going to talk about converting moles into grams and grams into moles using what's called the molar mass.